Thanks so much for tuning in today to talk about managing packages for open source data science. My name is Alex, and I'm a solutions engineering manager here at RStudio. Just a little about me so that you sort of know who I am and why I'm talking about this. I'm a former data scientist and a data science team lead. I worked on sort of healthcare, politics, economic policy kinds of issues when I was a full-time data scientist. And since coming to RStudio, I've been a solution engineer here for about 2 years. So that's me. So let's dive right in and talk about managing packages. So, data science is a lot like this delicious sandwich. This sandwich looks incredible, by the way. If you know how to make the sandwich, let me know, because wow. Anyway, data science is a little like making a delicious sandwich. Maybe it's an app that you're making. Maybe it's an API, a report, or a scheduled job of some sort. And it takes a little bit of planning, a little preparation, and a little skill to make something really, really great. Today, we're going to talk about sort of one important aspect of the open source data science, which is package management. And so we'll start talking about how package management can screw up your plans to make beautiful, delicious sandwiches or data science products. Some background on sort of how it all works, and then finally some thoughts on how it can be better and how it doesn't have to always be so painful. So let's dive right in. So first, sort of the pain. So one reason this can be painful is that folks are blocked, right? You're blocked from installing packages. Either you don't have permissions to install on your machine, or you're blocked from public package sources like CRAN, Bioconductor, PyPI, and that's a big problem. Or you have no way to share private packages. And I will say that there are some organizations that have bans against installing stuff to your own machine, and there's sort of no way around that. But hopefully, what you can come out of this presentation with is some information on sort of how to work with your IT team to get to a situation to do the work that you really need to do. And sort of that leads into the situation of it feeling like IT and data science are at odds. And this isn't so surprising, right? Like data scientists want the software they want, and they want it when they want it. And that's not necessarily always IT's concern, right? IT or admins have a lot of concern about platform stability and security. And those things don't have to be at odds, but they can be. And so that can be a problem. There's the issue of fragility. When you're sharing your project with somebody else, are you confident that they'll be able to open it up and actually use it? Or might they open it up and find themselves stuck because they don't have the right package set? And then lastly, sort of when you come back to a project in the future, right? This is just a form of sharing with future you, but how confident are you that your package set hasn't changed in the meantime and you can sort of get back to the same state? And so to be completely clear, you can't fix all these problems. And particularly if you're just a lone data scientist, it may not be possible to fix all these. You may need some help from others at your organization, but you can set yourself up for success here. And so let's talk a little bit about how. I love to cook. And when you're talking about cooking, there's this concept called mise en place, which means putting in place in French. At least that's my understanding. I don't speak French. But what it's really about is you sort of cut, measure, and prep all of your ingredients before you ever turn on your stove, right? So by the time you're sort of turning on the gas, by the time you're starting to cook, everything is in place and sort of ready to go by that time. And so one of the reasons is that you can't guarantee outcomes, but you can really guarantee your process. And so that's what sort of the mise en place step is meant to do when you're cooking. And you can do something very similar, right? Package management is very much like the mise en place of doing data science, right? It's getting all your ingredients, all your things in place before you go. So let's take a step back and talk a little bit about how do the ingredients get there in the first place, and how do you make sure they're ready to go when you're doing data science. We're going to stick with this metaphor. So your food starts at the grocery store, right? It's packaged up, it's on the shelf, it's ready to go, and you go and get it. And then when you want to cook something, you go and buy the right ingredients and you bring them home to your pantry, right? There's this shopping process. You go and you fill your shopping cart, you pay for it, you take it home. And it's very similar for packages. So that's this shopping thing where the stuff gets from the grocery store to your pantry. And it's really the same for packages. For packages, your grocery store is your repository. And so this is sort of an external place where you have all of your packages and they're stored sort of ready for you to go in an inert way. And then there's your library, and that is sort of your pantry where you keep your packages that are just for you and the things you're going to make. And that's sort of how that works. And so for many teams, the repository that they use is public, right? It might be public CRAN, public bioconductor, public package manager. Other teams choose to maintain private repositories, RStudio package manager, mini CRAN, something else. That's really fine. But the libraries are always private, and the libraries are, anywhere there's a kitchen, anywhere there's actual R or Python processes running, in the IDE, in a notebook, on RStudio Connect, in a Docker container, right? There's a library attached to that, and the shopping process is the install, right? So the sort of packages get from the grocery store repository into your private pantry library via the install. And so just to be a little more like precise about this, I have these two sort of side by side, but like really the way this works is that like the grocery store and pantries, many libraries are served by one repository, right? One repository provides packages for many libraries. And so let's dive in a little bit on like how that works. So a repository is just a file server, has a bunch of directories indexed in a particular way. And so just to be precise, right, like this is the link. You'll note it's a URL, right? It's a real like link to an internet site for a particular package on CRAN. Right now, CRAN is the main R package repository, public one. And so what you'll see here, right, is like this is for Windows. It is using the development version of R version 4.1. It is for the A3 package, which I chose because it is the alphabetically first package on CRAN. And it's version 1.0.0. And so this is like literally, this is the directory structure inside the CRAN repository. And so this is just a directory that's sort of organized in this particular way that R, when you go to install a package, it knows how to sort of walk this tree and get the package and the package versions that you need. One of the other important aspects of the repository is that the repository is not local. It is almost never the case that your repository is on the same machine as where you're actually doing your work. Very often the repository is going to be like actually in the cloud. It's actually gonna be a website like like that URL I just showed you. Or sometimes it's going to be an internal networked server. But usually, even if you're doing work on like RStudio server, it's almost never going to be on the same server. It's going to be a different server. That's very much in contrast to the library. The library is just a directory, but it's on the same machine as the running R process. And so you'll see like this is a Linux path to, inside my home directory. It's the R x86-64, Linux library. And you'll see like this is specific to R version 4.1. And the A3 package. And so, one of the big differences here is that libraries are specific to the version of R. They are not specific to the package version. And this is because like R needs a way to resolve definitively to a particular package. And in particular, the thing that arises here is like, some people wonder like, oh, why couldn't you just have a package version here? And the reason is that like, then when A3 has dependencies that it needs to go get, right, it needs to be able to, at some level, fetch those by name, right? It needs to just get the version that's there and not maintain many versions at once. And so this is the one of the big distinctions between the repository and the library is that the library has at most one version of any package. The repository has many versions of each package and even many versions for different operating systems. And in either case, you have like the thing that ties it all together is your settings on your machine, right? That tells your R or Python process what repository to use, what library to use, that sort of thing. And so one thing I want to make really clear is that like this is the same for R and Python. There are some minor differences in tooling, which we'll get to in just a moment, but everything I've talked about so far and most everything I'm going to talk about for the rest of this webinar is identical in R and Python. The sort of conceptual way that repositories and libraries house packages is exactly the same in R and Python. So let's get a little into the nitty-gritty here of like how these package installs actually work in R and Python. So let's say I go to install a package. In R, I do that with install.packages. In Python, I do that with pip install package. And you'll notice like here is one of the differences, which is that in R, I do all of my actual package management and installation from inside R, right? I type install.packages at a running R interpreter. That's different in Python. In Python, you use a separate binary to manage your package installs. Most often that's pip. It can also be something like conda, but either way, it's a separate thing from your running Python process. You don't do this in a Python interpreter, you do this at the command line. And so that's a difference in tooling, but in terms of what these tools do, they're conceptually identical. So in either case, what they're going to do is they're going to look at your sort of settings. In particular, in R, it's going to look at your options repos. In Python, it's going to look at your pip config. And from there, it's going to find the URL of a repository. And remember, this is going to be a real URL, either on the internet or a networked server. And from there, it's going to move that package into your particular library. Now, when I go to actually load a package in either R or Python, right, I do that in R with the library package command. In Python, I do it with import package. And so what I'm going to do from there is I'm going to, or what R or Python are going to do, are they're going to look at in R, the .lib paths, or in Python, the sys.path. Hopefully you've never had to look at these before because they just resolve automatically. From that, R or Python will know which library to look to, and will bring that back into your running R Python environment, and then you can use the functions from those packages. So, this was a lot of nitty-gritty, in-depth stuff. If this all felt like this was really exciting and interesting to you, like, congratulations, you're a huge nerd and you're in great company. So delighted to have you here. But if this sort of like went over your head a little bit or like didn't feel that important, that's great. That's totally fine. You should never need to manage this directly. But I share all this mainly to make the point that you can see why this is a little bit frustrating, why there's no sort of like single silver bullet to make this all work. Successfully managing a package environment requires, at least 3 different components, right? It requires the repository, the library, and the settings that tie it all together, right? All 3 of those things need to work. And so there's no single silver bullet to make this all just work. That said, there is a happy path. It is possible to make this delicious sandwich, whatever it is. And it's not even that hard, but it's you're going to want to do some planning up front. You're going to want to do your mise en place. And so we're going to talk for the rest of this talk about 2 ways that you can make this better. And the first is to develop a package management plan with your IT department. And the second is to have project-specific libraries that you can manage as an individual data scientist. And so from here, we're going to get to the package management prime directive, which is a little grandiose, but I like the slide. So we go. And so the first is that, repositories should be as broad as possible, right? These should be managed centrally if they're being managed at all, and they should try and serve as many users as possible. That is the opposite from libraries, which are specific. One other thing I should mention about libraries is that they are pull only, right? You have to pull packages to your libraries. And so, that means that the data scientists should have control of what they pull into their own libraries. This is sometimes a point of friction between IT teams and data scientists, and it's worth sort of having a conversation with your IT team about how you can safely manage libraries as the data science team, because we see many people doing it quite successfully. So to take a dive in a little bit on that, like, who manages each of these things? So on your repository, like, you don't necessarily need to manage a repository. A lot of organizations choose not to manage a repository, and we'll get in a minute into why you might want to. But many organizations choose not to manage a repository. If you are going to manage one, that's generally on IT or admins. And sometimes you have data scientists serving in this role of sort of the data science platform admin, and that's fine. But it's good to distinguish what you're doing as a data science platform admin versus as a data scientist. And so most often we see IT admins managing a repository because the job here is, to stand up a server, to network it correctly, to make sure that it's available to users, to make sure that it stays up, has the appropriate amount of stability and security. And so these are really IT admin tasks in terms of managing a repository. On the library side, that really falls to the data scientist to manage either a user level library or increasingly, and as I'm going to suggest to do here, a project level library, right? An individual library that corresponds to a single project is the safest path, because then you know that even if you do other projects, you won't have to worry about breaking your project library. And then the settings that tie them together, right? Like if you're on a server, like RStudio server, this most often is administered by the IT or the admin. If you're on the desktop, this is usually administered by the individual data scientist. And so, then the question is like, how do you manage this? What are the tools that you use? So on the repository level, obviously we recommend using RStudio Package Manager as the package repository for CRAN, Bioconductor, and PyPI repositories. There are also open source products like mini CRAN that you can use if that's what your organization or you prefer. On the library side, there's Renv and virtual env, and this is another difference between R and Python. In Rland, the two options that most people use to do this are either packrat or Renv. Renv is a full replacement for packrat, and in fact was written by the same person. So if you're using packrat, upgrade to Renv. If you're not managing project-specific libraries, start doing it, use Renv. On the Python side, there are a ton of options for how to do this. There's virtual env, there's conda, there's pyenv, there's all these different things. And if your organization has a standard, that's fine. Use what you want to use. But if you aren't using anything yet, I would encourage you to use virtual env. It's relatively simple. And as far as I've seen lots of organizations sort of successfully use virtual env. And so that's the one that I recommend most often. And in terms of the settings, that can be configured inside the RStudio IDE if you're using the RStudio IDE, or you can use config files like rprofile or rprofile.site or renviron or renviron.site to set those settings. Great, so let's talk a little bit about why organizations want to manage private repositories. And the main reason here, right, is that when IT needs to control the set of packages that's available to people, this is how you do it. And I want to emphasize this, that if you are in an organization where you cannot install R packages on your machine, you're in a broken state and you need to figure out a way to convince your IT team to let you install stuff. It's really, really hard to work in that environment. One answer is to get a centralized server, but the other answer is to allow installs only from a private repository, right? So that's the reason we see people standing up private repositories, and that is because they're in offline or air gap situations. That is, there's no access to the internet from where you're installing packages. Now, that's a common sort of thing in high security environments, and that's totally fine. The solution is to have a repository behind your firewall and then allow people free and open access to that repository and lock them from using any repository outside the firewall. Similarly, if you have to validate package sets into your environment, right? If that's why you can't install packages because you can't install sort of anything, again, the way to solve this problem is to have the repository be the gateway, right? The repository chooses what are the sets of packages people are allowed to install for safety or security reasons, and then what they can install. This can also work really well if you have projects that require sort of package validation, and then like once those packages have been validated, you can only use that set. This is a great way to administer that, right? Like you administer the IT or admin administers it at the repository level, and then data scientists are free to install whatever packages are available to them from the repository, but they can't get anything else. All they can get is what's in the repository. And then the last piece here is if you're doing private internal packages that you're developing locally, having an offline repository can be a great way to do it. So for the rest of this presentation, we're going to talk about how to do your mise en place with RN. We're going to talk about some of the ways that RN can be helpful here, and that is by isolating your libraries on a per project basis, which we've been talking about sort of being a good thing. Using a snapshot of repository from RStudio Package Manager to ensure reproducibility later on. Sharing or restoring a project when you're sharing with a colleague or when you're coming back to a project after some time. And how to start a new project and easily sort of do your mise en place to make sure that this works in a way that you're happy with. So first, let's open up this very ominously named package fails project here. And so, what I want to point out is this is some code in an R Markdown document. It last ran in 2018 in June. I'm not going to get into really what this code does. And so what I'll say up front actually is like, what this code does is pretty silly. So please don't judge me based on that. What I wanted to do is I wanted to find an example where upgrading the package versions would cause something to fail. And in a tidyverse package, because since we make the tidyverse packages here at RStudio, I figured we could blame ourselves at least. One thing I will say is actually it was hard to find an example of this working. If you saw Hadley's talk at RStudio Global, the tidyverse team is making a huge effort to not break people's code, and it was actually quite difficult to find an example where this fails. But anyway, so here's code that ran in 2018. And so I'm going to try and run it today in 2021. And what we're going to find is that this code, let me make this a little bigger so it's easier to see. This code no longer runs because the argument data is missing It looks like it's there, so I don't know what's up. I mean, I do know what's up, but like, this is the kind of thing that could take forever to debug and sort of get stuck here. If the eagle-eyed among you will notice that the problem is actually that this argument was renamed to dot data in tidyr later. And so like, if I look here, what version of tidyr am I running? I am running tidyr 1.0.2. So I happen to know that as of June, and let's look again at when this last ran. This ran in June 2018, and as of June 2018, the version of tidyr back then was like 0.8.1. And so what's happened is tidyr has gotten upgraded because I did something else on my system that bumped the version of tidyr. And so now my code is broken. It's just broken. And that's really frustrating, right? There are ways to fix this, but I got to spend time fixing it. It would be ideal if this had not happened in the first place. So let's go to the much more friendly named Renv working example here. And what you'll see is this is exactly the same code, identical code. And this is going to run. R markdown render, boom, done. And now I've got a version that works today, right? Like this ran today, just now, 2/17/2021. And so what's the difference, right? Like if you've been paying attention, I'm sure you've realized the difference is that I'm using Renv here, but like, let's real quick just check. So like inside the working version, the version of tidyr is 0.8.1, right? Whereas in the non-working version, it had gotten upgraded in a way that I didn't really mean for it to. So that's great. And the way this, to be transparent, let's check out those .lib paths, which I mentioned was the way that it looks up where the library is. And so you'll see like the library in this version, this is like my user level library, and this is the system level library. So like at some point in my user library since 2018, I've updated the version of tidyr, which is not very hard to imagine. On the other hand, inside this version that works, the lib paths point to, this is my home directory. So like this is inside the Renv working. Inside this project, there's an Renv library that is going to be keeping sort of this package safe for me for later. So that's great. Like Renv has done its job. I am keeping myself safe. So that solves one problem, right? Like my package versions will stay consistent as long as I keep this Renv project with this project. So what happens now if I want to install another package? Let's say I want to install ggplot. Now, I did install package ggplot. Oh, great. So it installed ggplot 2.2.1. So that's great because ggplot 2.2.1, I happen to know, is the version from June 2018. Currently, ggplot 2 is on 3.3.3, which is not the version I want, right? Like that's too new. It might break. So how did I get ggplot 2? And of course, if I look at my options repos, that's the answer, is that my repo here is pointed at a public RStudio package manager. And I happen to know that this is the URL format that means that this is a dated repo. And so let's look at what that means. So here's RStudio package manager. This is public RStudio package manager, packagemanager.rstudio.com. You can go there and use it as you wish. It's free and available to use. And so what I'll see is that if I go here to the setup pane, I can get, if I go back to June 2018, there's that 72, right? That is from that date. So what that means is that every time I install packages from this repository, they will work together as of June 2018. And so I never have to worry about installing a new version that's going to mess things up because they will always play nicely together. The other thing I will say, and this is again a thing that's different between R and Python, is that in R, you need to specify that you want binary repositories for your operating system. They are specific to the operating system, and you can change that here to choose the right repository. This is really important just because using binary repositories can really, really speed up install times by like several orders of magnitude. And so it's worth it to choose a binary repository. That's not necessary for Python. Python by default will always give you the binaries for your system. So anyway, so now we know how I got this, how this package worked, that sort of thing, why my tidyr works. But how is this being maintained? And so what Renv does is Renv saves what's called a lock file. And so this lock file contains my version of R, right? It says it's our version 3.6.2. This has that repository in it, right? That's that repository that I used. And so that, ooh, zoomed out too much. This is that repository that I had set, when I started this project. And then I have a list of all of my packages, what version they are, what repository they're using. If I have GitHub packages, it will record that as well. Git packages in general, not just GitHub, but also GitLab, Bitbucket. And so this gets recorded in my lock file. And so if I want to make another project, let's say I want to share this with my colleague, right? All I need to do is I need to share the Renv lock file with them. So here's what I'm going to do. I'm going to take that Renv lock file, and I'm going to copy it to the broken version. So all that I've done, right, like this is the version of this project that does not work. TidyR is wrong here, right? This is, actually, I got to load the data. And TidyR does not work here, right? This is, again, that wrong version of TidyR, the new version of TidyR. And so now what I'm going to do is I'm going to do rn init, which will stand up my Renv virtual environment specific to this project, and it will restore it in particular from the lock file. The other thing I just want you to notice is that was almost instantaneous in terms of restoring that lock file. And the reason is because Renv maintains a user level cache. So if I've ever installed these packages before, they automatically get restored, and it is super fast. And so now if I go, you'll see package version TidyR 081. Awesome. Now I've got the right version. Now I can run this code, and it just works, right? So this is really awesome, and it makes an easy way to share a lock file with, or to share a project in an environment with somebody else or with future you. Great. Okay, so one more question that comes up all the time is like, okay, great, how to do this, but like, how do I do this for a new project, right? Like, how do I start this afresh? And so it's really quite easy. When I go to new project here in the RStudio IDE, new directory, I'm going to start a new project. I'm going to call this my new project. And now all I do is I'm going to click here, use Renv with this project. And now Renv is going to be set up with this project as it starts here on RStudio server. It's going to set up a new project for me with my sort of folder there with my rproj file, that's the project folder, and an Renv library that is attached to the project by default, which is really sort of a nice thing to do here. Now, so what this means is that whenever, if I go to install packages, oops, if I could spell it right, that would help. It will install, again, it linked in from that cache super quick. And so, that's the part of using Renv. Now, what if I want to use a snapshot of repository? So there's a little bit of judgment here around what the date is to choose. You want to choose a date that sort of like works for your project. My general recommendation is to choose a date that's sort of like around the time your project is pretty stable. So you probably don't want it to be like the day you start the project, but maybe like when the bulk of the coding is done and you're thinking, okay, it's time to save this for later. You can do Renv modify and go in here. Oh, here's my like Renv block file, and I can edit. Let's get a repository that's like more up to date. Let's say I want to do like yesterday. I can get that lock file, the right repository. I just put it in here. And now when I start a new session, it's going to automatically set my repository to be the right repository. It's going to take just a second here to reload. But after it reloads, what you'll see is that it's going to be that updated RStudio, that updated version of the package manager repository. Now, if I want to say the way, one other thing just to be aware of is the way to capture dependencies is I'm going to save an R file here. And now when I do Renv snapshot, it's going to introspect on those files. And it's realized that I need ggplot2 in here and all of its dependencies. So this makes it really easy to use. You can also set up auto snapshots so that it will snapshot anytime you type install.packages inside this project folder. Great, so that's basically what I wanted to share in terms of using Renv. And so we're gonna wrap up now. And so just a couple things to review here. So the thing you wanna do, right, is two things to encourage you to do. do a package management plan with your group, right? How are you managing repositories? What are those settings supposed to be the default repos? And how are you managing libraries? And before you start your individual data science work, do your mise en place. Use RN, and you know, I just showed off how to use RN for R. The process of using virtual end with Python is really, really similar. Really similar. If you want more information about this, we have a website, environments.rstudio.com, where you can feel free to check out more information on this. And if you're interested in RStudio Package Manager, if that seems like something that your team could use, feel free to send us an email at sales@rstudio.com, and we can talk more with you there. I'm going to pull up the Slido questions. Okay, also interested in RStudio's Docker images, but they are advertised as experimental. Any idea of when they will be out of experimental? No, I don't know that we have any plans to make them, you know, more strongly supported than experimental now, for the time being. At this point, you know, if you want to use them, you should feel free to use them, but no imminent plans to stabilize them as far as I know. Oh, this is a great question. Somebody asks, interested in the advice that users should manage their own libraries. To that end, what's your advice on the role of a centrally managed site library? This is a great question. I love this question. This is a question that, you know, I think a lot of IT folks yeah, it's a really good question. The short answer here is that I do not believe it's necessary. It is definitely the case. I strongly recommend against trying to disallow users from being able to pull their own packages, right? Like data scientists should be able to manage their own specific packages for themselves. And the reason for that is that, like, for example, let's say that, you know, I have just a centrally managed set of packages, then like somebody has to do that management, right? Then IT has to manage that library, which can be very difficult in terms of managing not only what packages, but what versions, what's installed, what date was it installed, how does that correspond to the project, right? This gets really complicated really, really fast. And so I strongly recommend against having all the packages in a centrally site managed library. So there's another version of this that's a little bit softer, which is like an admin stands up a sort of starter set of packages that are centrally installed, and then users can install their own packages on top of that, but like they can use the starter set if they want to, so that you know, that works more easily. And there's nothing wrong with doing that. It's totally fine. In most cases, it is unnecessary. We tend to find, you know, the big reasons people want to do this are because they want to, you know, sort of make things easier for data scientists to sort of get started. In general, folks can install their own, right? If you can library a package, you can install it. And if folks are having trouble with like system level dependencies, this is where we sort of recommend centralizing those resources on a server as opposed to everybody working on their own desktop. So again, even on a server, we recommend everybody managing their own individual libraries, not sort of a centrally managed site library. So that's a great question. Here's another great question on what does RN save? Does it include all of the packages that are installed or only those actually used inside a project? Yeah, this is a great question. By default, if you do a snapshot, it snapshots only those packages that are in use at the current time. And what that means is that like it can find them somewhere in like a library call or a like, you know, a colon call, right? If it can find either of those, it will capture those as dependencies. This does sometimes get people into trouble if people are doing this. And then like lapply lib install.packages, like this will not get picked up from our end and also is a bad process, right? If you're doing this, this is just like a plan. This says you need our end. So if you're doing this, don't do this. Use our end instead. It works way better. It captures versions and not just packages, and also doesn't mess up, right? Like this could mess up somebody's entire package environment. if you turn, there is a way in RN to turn on auto snapshotting, which is basically any package that gets installed will get snapshotted. And so that can end up being like more than the packages you actually need. And then there's a prune command basically that allows you to prune the RN library back to only the things that are actually being used. Great question. Let's see. Do you have a free version of Package Manager? Yes, it's the public one. RStudio Package Manager, packagemanger.rstudio.com is public package manager. If you want something behind your firewall, an internal version, that is where our pro product comes in. So good question. Package Manager provides a way to control the list of packages it caches. When will it do the same for Python packages? No guarantee on when. It is under active development by the Package Manager team and will be out shortly. For those of you who aren't quite aware, Package Manager, the private version, supports Python repos, PyPI repos. Currently, though, it only supports full mirrors. It does not support subsets and that sort of thing. This will be forthcoming in future versions of Package Manager. What is your recommendation to use a mix? And this will be the last question. I think we're running out of time. What is your recommendation to use a mix of validated public packages in one environment in a highly regulated environment? Yeah, this is a great question. So there are a bunch of different ways to do this. The most common way we see this done is, oops, I'm going to go back to, this is our internal sort of demo version of Package Manager, is you can create a validated repository here inside RStudio Package Manager. And that can sit aside, right? Like you can have multiple repos. And so like you can do this yourself. I'm showing you an RStudio Package Manager, but you can do this in other tools. This is not an RStudio Package Manager specific thing. But I happen to have an example here in RStudio Package Manager. You can create a validated repository that has only those validated packages in it, right? And you can specify the versions and the sort of packages. And you can have that sitting beside, this is a full CRAN mirror, right? And so what you can do then is you can say like, okay, for the validated projects, use the validated repository, right? And you, again, just go to the setup tab here, make sure you're using the appropriate binary repository. And if you want to, choose a date if you want to. If you're doing sort of a more public project that doesn't need that sort of high degree of validation, just use the sort of all-in public repository. Or the alternative is, you could have the validated for the validated repository and the public, you could just literally use a public CRAN mirror. This isn't quite as ideal because then it's a little easier to mess up, but that's sort of the recommendation there. I know we did not have time to get to all the questions here. Unfortunately, we're I think out of time. I will be putting together some more materials on this topic and sort of emailing them out. So I really appreciate all the questions. I will take a look at all these questions and we'll probably include a little FAQ in some of the future documents we send out, and we'll try and address as many of these as possible. Again, really, really appreciate everybody's time today and for sticking with us through all the technical difficulties today. I've never quite had a webinar go like this, but I really appreciate everybody sticking with us, and hope you got something out of the time today. So thanks so much for joining, and look forward to hearing from you more soon.